previous sections, we were given a cubic and we sketched it. We put x equal to 0, we put y equal to 0, we did synthetic division, we did the first derivative, we put that equal to 0, we found the x values of the turning points, we substitute back into f of x to find the y values of the turning points. We then looked at the table of the first derivative to see if it was approaching, if it was concave up or concave down. We also looked at the double derivative, f double prime, a second derivative, and we saw if it's negative, it's a maximum, and if it's a minimum, it is positive. Therefore, what if we turn this around? We're still doing cubics, and we're going to look and we're going to say a cubic equation in the form of something. Now, what I'm going to do is I'm going to turn it round. They're going to, let's put down here cubics, okay? But we're going to turn it round. I'm going to say, given some points, find the equation. So if I give you some points, we have to find the equation from those given points. It's essentially just doing it backwards, that's all. So they're going to give us two scenarios. So the first case 1 or scenario 1 is we've got, let's say we are given the roots or the x-intercepts. If we are given the roots and the x-intercepts, therefore we are given a graph, and I'm just drawing it basically like that. We are given, I'm going to go for green, green roots, green shoots. That's economics, isn't it? So I've got here x1, x2, and x3. Now, these are given. And yes, you have to know this. So we say, all right, the general form of a cubic we know. Y is equal to ax cubed plus bx, oops, a daisy, bx squared plus cx plus d. Now you can also, another version, remember on a quadratic we did completing the square, didn't we? We put it into turning point formula. We also on a quadratic put it into if the roots are known. We had a x minus root 1 times x minus root 2. That was also a way it could have been given. Well, guess what? That's irritating. Guess what? What we're saying is that we can put it into a similar to the quadratic, like that. We say that y or f of x, please, is a, and we can put it into x minus x1, x minus x2, x minus x3, or if you prefer a, x minus root 1, x minus root 2, or x minus root 3. We can do that. And then we can find out what a is from there. Okay. Please note, okay, so basically all we're saying is that we put it into that form. Basically we read off. How do we do it? Okay. We read off the graph, R1, R2, R3, and put into the formula and calculate A. All right? Simple as that. How do we calculate A, you ask? But how? Simple. You are given another point. X, Y, given values to plug in. That's not too difficult at all. We're going to do one or two of these, and we're going to do more in example time. All right, then you put it in and find A, multiply it out. Or, number 2, You are told a, the coefficient of x cubed, remember, ax cubed in the actual question. They will say y is equal to, they will say something to this effect. Y is equal to x cubed plus bx squared plus cx plus d. Be very, very careful. Many problems are put as f of x given is, I keep wanting to write the standard form, x cubed plus ax squared plus bx plus c. Please be careful. They often put the a, b, c down there like that. I don't do that because it confuses the standard form, but please be aware when you are checking, in this case, the a over here is actually 1. But they've moved it down, find a, b, and c as unknown numbers. You will encounter those, guys, I promise you. In the papers and in all the research I have done, there are plenty that are like that. Okay, so we're given basically those numbers. All right. Now, also remember this. Here's another form. Remember, a cubic has to have the 3 as we've got it. So we've got y could be equal to a times x minus, I'm going to go root 1, x minus root 2. That could be squared if it's repeated. I'll explain what I mean in a second. Okay, when we look at one, I'll explain in a mo. Okay, it's a repeated root x2, similar. Okay, and essentially what we're saying is that it's turning. If it's repeated, if a root is repeated, it's a turning point on the x-axis. Just remember, not axis. So what do we say? We say, cool, it's a turning point on the x-axis. We'll get to these in a moment. We're just going through some theory. Or scenario 2. What is scenario 2? You are given a stationary point and another point. Usually they give you an equation and they tell you find the A, B, or the C, or the D, or the whatever the case might be. These are the kind of things, and we're going to end up in here, usually simultaneous equations result. Usually simultaneous equations result from that process. Now I know it's a lot of hot air that I've just been spouting off. Let's look at an example. Okay, let's just pick up on an example here and do one or two. Example. Our first example is a cubic equation. A cubic equation of the form y equals, or f of x, ax cubed plus bx squared plus cx plus d. Okay, cubic at that form with roots -1 and 0 and 3 and 0. 3 and 0 and -1 and 0 with a y-intercept at -6. The last thing is the point minus 1 and 0 is a turning point. So they've told us, now they say, right, calculate A, B, C, and D. Well, straight off, let's have a look at the information they've given. They have told us y-intercept at that. Therefore, I can immediately say my formula is, I'm going to leave it as y is equal to ax cubed plus bx squared plus cx, and they told me that is minus 6. That is my first one. Okay. Now, the next one I can say is also, what else is given? We are told that the roots, and the roots are minus 1 and 0 and x minus 3. So let's put it in. We're told the roots, so it's in the form y is equal to a times x minus root 1, x minus root 2. Now remember, I'm going to say x minus root 3, or a x minus root 1, x minus root 2 squared, if that's the turning point. And they told us that it is. This is a x plus 1 all squared and x minus 3. Because they've told us minus 1 and 0 is a stationary point. Just check that I've got it. See? This piece of information here, minus 1 and 0, is also a stationary point, a turning point. And look where it is. It's minus 1 and 0. It's a root as well. So therefore, turning point and a root, which means it's a repeated factor. Therefore, I can put it in like that. Now you say, where does that minus come from? Just a little thing here. A x minus 1 and x minus plus 3. You put the number in as it's given, like so. Now what do? I multiply out. Okay. I multiply it out, and let me just multiply this out, and it comes to, right, I don't need to. I'm given another point. I'm given another point, 0 and minus 6. Thus, we can go back and we can say minus 6 is equal to a times 0 plus 1 squared times 0 minus 3. We end up with minus 3a is equal to minus 6. Therefore, a is equal to 2. Now, what do? I know a. The next step, knowing a, is I go along and I say, okie dokie then, I have to multiply out, because I now know 2 times x minus 1 plus 1 squared, x minus 3. That's going to be 2, multiply this out, x squared plus 2x plus 1 times x minus 3. Okay, and we keep going and we end up with 2 times x cubed minus x squared minus 5x minus 3. Therefore, now 2x cubed minus 2x squared minus 10x minus 6. And this is the equation. Therefore, a is equal to 2, b equals minus 2, c equals minus 10, and d equals minus 6. All I did is I rewrote it, and I put it in terms of the original equation with the roots. and I used the other point to work out what A was. Here's another example. Another example over here is this one. A cubic graph of the form f of x equals x cubed plus bx squared plus cx plus d has known roots x equals minus 1, x equals 1, and 1, 0 is a turning point. Calculate BCD. Okay. So what do we know? Once again, we can start off by saying f of x is equal to, because we've got here minus 1, so I'm given roots, x minus root 1, x minus root 2, and x minus root 3. Let's see. So in this one, once again, we've got, there's my a times it, it's going to be a. But in this case, a is given. A is given. It's 1. So it's 1 times x minus 1, all squared, times x plus 1. Why x minus 1 all squared? Because it's given as a turning point. Okay. X equals minus 1, x equals plus 1, right? It's given as a turning point as 1, right? So it's minus 1, and the other one, this is the minus 1 root. Is it not? 1, 0 is the turning point. If that's a turning point and a root, I duplicate the root. Okay? It's a duplicate root. Okay, so there's my duplicate root. The last thing now is we're going to go and you multiply that out. When we multiply it out, we end up with the following. X cubed minus x squared minus x minus 1. Therefore, A equals 1, B equals minus 1, C equals minus 1, and D equals plus 1. My bad, sorry, there's a plus 1 there. Okay, that's how we do those. Our next one is slightly different that we're going to do. Given the turning points, here's another example. Given the turning points of a cubic are 1 and 0 and 3 and minus 13. Three and minus 13. And it's of the form y equals ax cubed plus bx squared plus cx minus 4. And a equals 1. So straight away we can say y is equal to x cubed plus bx squared plus cx minus 4. Then we know this is the y-intercept, is it not? That is the y-intercept of our cubic graph if we wanted to plot it, which at this point in time I don't. Now, what is my next step in this process? Let me just bring that down. you can see that this is the function that we've got. Right? The next thing is they have told us that we have got turning points. Stationary points are there. When they talk about stationary points, what do? Anybody know? Yep, you differentiate. So dy by dx to find those points is equal to 3x squared plus 2bx plus c. And what did I do? I put it equal to naught. So I put f prime of x equal to naught to find the x value of a stationary point. Let's just recap this. Hold on. The process said take the first derivative, put it equal to naught, and solve for x. That is the x value of the turning point. But I've just given you the x value now of the turning point. I have told you that, let's just think it through. We know that at x equals, we just check myself, x equals 1 and x equals 3, that f prime of x is equal to naught. Therefore, I substitute in. Back substitute. Just go through it again in your mind. What did we do? We take the first derivative, and normally we would put it equal to naught and solve for x. And we'll get 2 x's. Those are the maximum and minimum points of our cubic. In this case, I have told you that the x value you would get is 1 and 3. Just check, it is 1 and 3, yes. Therefore, I can say, 3 times 1 squared plus 2b times 1 plus c must be equal to naught. In other words, at x equals 3, the f prime of x is equal to naught, which is 9 plus 2b plus c is equal to naught. Whenever I write 2b, I always want to do the whole, or not to be. Okay, so that then is 2b plus c is equal to minus 9. And yep, remember I said, we also know that f prime of x equals naught at x equals 3. Okay, just remember I put a 1 there. Okay, at 1. So I subs 1 into the thingy. But I also know that at 3. Therefore, f prime of x is equal to 3x squared plus bx plus 2bx. Okay. Plus 2bx plus c is equal to 0 at x equal to 3. So I substitute 3 in there. Okay, 3 times 1 squared. Look where Kevin's brain was going here. 3 times 1 squared is 3. And that's a 3. My error, sorry. My apologies for that. It's a minus 3. Now I say 3x squared. So now I put in x equal to 3 and I say 3 times 3 squared plus 2b times 3 plus c is equal to naught. What do we end up with? We end up with 27. 27 plus 6b plus c is equal to naught. Therefore, 6b plus c is equal to minus 27. This is then equation 2. What did I do? I said equation 2 minus equation 1. Okay, let me just put a thingy under it, and there they are. That's going to be 4b. That's going to be that. Minus that is going to be minus 24. Okay, because it's minus 3 is 24. B is therefore going to be equal to minus 6. How do I then find the next one? I'm going to find C. Back subs. So I'm going to back subs into anyone. I chose 2 times minus 6 plus C is equal to minus 3. Minus 12 plus C is equal to minus 3. Therefore, C is going to be minus 3 plus 12, which is equal to 9. Thus, my final equation is going to be equal to y is equal to x cubed minus 6x squared plus 9x minus 4. There's C, and there's the other one. And that is how we're going to do those, all right? As I say, we're going to do the infills and bring in more of these. There's quite a number of worked examples in the book for these as well, in all of the textbooks I've been through. Some more advanced than others, granted, but as long as you get the hang of the fact that when they tell you that you've got stationary points, take the first derivative and put it equal to naught, and then fill in the x value at that point. That's what you have to do. It's kind of the opposite of the interim step that we were using. Thanks for watching. Cheers. We're going to continue with the next step, which is optimization of functions. Have a good one. Bye.